Now we're going to look at one concept that's used in business, which is called the elasticity. In business, usually, let's use P to represent price. Usually when P increases, the price increases. D, the demand, usually decreases. And oftentimes, you want to maximize your price, right? So you want to increase your price. Say for instance, if you increase your price by 1%, it will hurt the demand. But as long as the demand doesn't hurt too much, that will be still pretty good. So usually if the demand decrease is less than say 1%, that's pretty good. Okay. So usually because it's decreasing, we usually use negative 1%. In other words, sometimes it's useful to look at a ratio. What ratio you want to look at? The change in demand over the change in price. Usually we measure that in percentage. The change in demand in percent over the percent of change in price. So this ratio is very meaningful. It tells you every percent change in price, how much change you will have in demand. So let's put that into a mathematical expression. How do we find the percent of change in price? You're going to do this. The change in the price divided by your original price. So delta P means the change in price. So that's the percent of change in price, which is in the denominator. And the change in demand, similarly, you're going to have the change in the demand divided by overall demand. So this means the percent change in demand, right? And similarly, the bottom one will be the percent change in price. And then now in calculus, we talk about derivative. We want to see how what if you just change a little bit, tiny bit in price, what would happen in the demand? So in other words, we want to look at when the price change is approaching 0, what would happen with this ratio? So this limit, this guy, is actually defined to be the elasticity. And if you can recall that when the delta P approaches 0 and with the limits, that actually it involves the derivative of this function. It involves the derivative. And the notation, if you can recall that we use, will be when we use the derivative notation, we don't use delta anymore. Instead, this becomes, let me erase some of those. So now, when we introduce the derivative notation, so basically this becomes, the delta D becomes dd. Sounds a little weird, but lowercase d with capital letter D. And then the bottom one will become dp. If you rewrite that, this will be P over D, and then here you have dp. Okay, so this guy is gonna be called the elasticity of P. This P is the input, the price change is the input. It affects the output, which is the change in demand. So therefore E of P is defined to be P over D, and dp. Please do not read that as dd over dp, because That's just the derivative. So with that, we're gonna so this is the introduction of where this elasticity come from. So it comes from the ratio. Let's take a look at the demand for processed pork in Canada. The demand is given here. And then let's find the elasticity of the demand. So according to what we just developed, this is going to be P over D. The demand is 286 minus 20P. And this dP means the derivative with respect to P. In other words, you need to find the derivative with respect to P. So which is negative 20, right? If you find the derivative with respect to P, that's negative 20. And you see that we can actually cancel the top and the bottom by 2. So you're left with negative 10p on top, 143 minus 10p on the bottom. Now let's take a look at the domain. Okay, here the elasticity should be always less than 0. Elasticity should be less than 0. If you can recall what's elasticity, we say that elasticity is percent change in demand, right, divided by percent change in price. So if you increase the percent change in price, you really should expect percent change in demand will decrease. So therefore this will be negative, this will be positive. So as a result, it should be negative. So with that, you can quickly identify this guy should be greater than 0, which implies P has to be greater than or equal to 0, less than 14.3. Now let's take a look at the second part. Demand is elastic if the elasticity is less than negative 1. And the demand is inelastic if the elasticity is in between negative 1 and 0. And how do you make sense of that? Actually, you want to take a look at this ratio. Just think about this. If you increase this by 1% in price, if the demand decrease is less than 1%, I'm going to use negative because it's decreasing. If it's less than 1%, that means, hey, that's pretty good. The market doesn't seem to be very sensitive to the price change because you already increased price by 1%. The demand doesn't change more than 1%. So this is good. That's why in this case, when this is in between negative 1 and 0, it is inelastic. That means not that sensitive. So for what price is the demand for pork elastic? Now basically we're looking for the cutoff point. So we're gonna let E of P be negative 1. We want to find that price point so that we can tell whether if it's more than that, if it's less than that, that's inelastic. So E of P is negative 1. That means this guy should be equal to negative 1. And you can pause the video and quickly solve that by yourself and compare that mine with yours. So you solve this equation, and it turns out P is 20P is equal to 143 and P is 7.15. Now so E of P, the elasticity is less than 1, which means elastic when the price is greater than $7.15. So just use your common sense. Of course, if your price is higher, then it will be more sensitive, right? And then E of P will be in between negative 1 and 0 when the price is less than this guy. Okay, so which means inelastic. How about we add one part to this particular problem, say C. So I'm adding an extra part here. If price changes from $8 to $8.50, what is the approximate percent decrease in demand? So in this case, we approximate the elasticity at value 8. So if you plug this into the function, and you get this is about negative 1.27. Keep in mind that the elasticity, which is negative 1.27 in this case, what is the elasticity? Is the percent change in demand, right? Divided by the percent change in price. So here, what's the percent change in price? It's $8 to $8.50. The change in price is 0.5 divided by 8 to get the percent change. This is actually turns out to be 0.0625. So, in other words, this part, percent change in price, is equal to that, and we need to find the percent change in demand. So therefore, percent change in demand is going to be about negative 1.27 times the percent change in price, which is 0.0625. And then you can see 0.079, about 0.079375. So that's it for the part C. I think I would like to include that to show you how this can be used to kind of estimate when you decide to increase price, and how would you estimate the percent decrease in demand. A very good example here.